Welcome to a new video on my home automation OpenHub and NodeRED series. Recently I released a video on this Beca thermostat which communicates via Modbus, and I show you how you can connect it directly to the Raspberry Pi using an RS485 to USB converter, and how to access the data, the temperature and all the settings data within NodeRED, and how to establish two-way communication between NodeRED and this device. And actually over the weekend I was looking around in my parts bin, and I have found this device which I have ordered such a long time ago that I can't find the purchasing link anymore. And what this is, it's an RS485 to TTL converter. It is very easy to spot this chip just by the looks of it. So on one side, on the component side of the PCB, you have this screw mount, and on the underside, on both ends, you have 4-pin pin header connectors, and that's basically does all the conversion. And what I have done now is I've just used one of my VMOS D1 Mini to write a simple sketch which basically queries this device every second, and then all the data which is acquired from the Modbus device is then converted into MQTT and sent to NodeRED. So I think this would be an ideal mode for somebody who doesn't have a physical line or cable between the Raspberry Pi and the thermostat, so they are looking for a wireless solution. And of course this is a very cheap mode as well, because a VMOS D Mini cost about maybe £2.5, and this transceiver chip is also £1 or £2. So you can have this for probably £3 or £4, or maybe just a little bit more. So that would be about $5 or $6 US. So probably like third of the price of the actual thermostat. And then, well, you can have it on wireless. Well, actually there is one more component that you need to buy, because I've also started building this PCB version with just a couple of wires. So yeah, of course you need a power supply, because you need 5 volts to power this unit and also the VMOS D1 Mini. I was thinking about taking the unit apart and see if I can, get 5 volts from an internal, power supply. But well, yeah, I didn't want to risk it at the end, and again, I don't know whether whatever regulator they have designed in there would have enough reserve to power these two devices as well. So I'm just using an external power supply. My intention is to break this video into 2 parts. In the first part I'm going to talk about the basics, so that would be suitable for somebody who doesn't really care how this works, but just wants to implement it and more focus on the NodeRED part, or whatever other home automation system they are planning to use it to, interface to, or just to read the MQTT messages. And in the second half of the video I'm going to talk a little bit more detail about the Arduino code which is running on this ESP. So if you have a different Modbus device and you want to build your own Modbus to MQTT gateway, I hope that my sketch is going to be a good starting point, because as I said in the previous video, the thing with the Modbus is that every device is different. They are using different registers, they are probably using different Modbus functions to either read or write data. This is using holding registers, but other devices might use coils or discrete inputs. So I don't think that a generic Modbus to MQTT sketch can be written, or well, technically everything is possible, so I think you can, but most probably it is easier to write specific sketches for specific devices, which I have done here. Also, I mentioned in the previous video that I am using a Beca thermostat, which is a fan coil version, but well, by the looks of their website, I think even if you buy a different version which is for water heaters or gas heaters, the registers that they use and the way they store, for example, temperatures and status and lock and time and date, is going to be the same. So hopefully this code is going to work for pretty much all Beca thermostats. But again, that's only an assumption at this point. As always, link to the Arduino sketch and the NodeRED flow is going to be in the video description. To start with, let's talk about the wiring. And this wiring is actually really simple, because all you need is the VMOS D1 Mini and this TTL to RS485 converter. There is no other passive or active components are required, just a couple of wires. And as you can see, this on this converter, we have 4 pins on one side, which is labeled D, D, E, R, E, and R, O. I don't actually know what all these pins in. I think probably DE is data in, and DE is probably data enabled, and then RE is receive enabled, and then RO is receive out, or something like that. Because to use RS485, you actually need 4 wires. So you need the 2 data wires, which is the DI and the RO, and also you need a transmit enable and a receive enable lines, and those are the middle wires, so the middle pins, the DE and the RE. And I just used you know, a couple of pins on the ESP to do that. So for data pins, I think I'm using D6 and D5, and for the enable pins, I'm using D1 and D2. But by the way, this is going to be documented in the sketch, so there is no point looking at the wires. It's probably the easiest thing is to look at the sketch and see how that works. And the only other connection we need is we need 5 volts and ground for the converter, which goes into the outer pins on the other side. And the other 2 pins which I haven't connected is the A and B. So those are the Modbus pins, which are also connected up here. And say it was just easier for me to screw these in. And as you can see, red is connected to A and white is connected to B. And that's pretty much it. And the sketch itself is rather simple. When the ESP boots up, it connects to a wireless network, then it also connects to your MQTT server, and then it does a few other things. So for example, there is a simple web server in there, which at the moment doesn't do much. It just states the device, which I just like, because at least I can tell, you know, if I'm seeing the new IP on my network, I can just query that in a browser, and then I can see what device this is. So that's just something for me. Otherwise, it's yeah, pretty much useless. So once it has done all that, it connects to an NTP, so that's the time server on the internet, just to get the current time. And the only reason this does that, because it then automatically updates the time and the day of the week on the Modbus device. So at least you don't have to do that manually. On boot up, the system is going, or the ESP is going to update the time on the device. And actually it checks the NTP time, I think it's every hour. So it would just keep updating the time on the thermostat based on the you know, the absolutely accurate internet time. And that's actually quite nice, because that would take care of the summertime changes as well. And once that is all done, then it queries all the all the registers, which is basically the holding registers from register address 0 to 10. So it is the same type of data that you have seen in my previous video, so that includes all the different states and the temperatures and everything. And then it puts all these values out as separate MQTT topics. The device also subscribes to a couple of MQTT topics on which you can set the different states. So you can power the device on and off, you can change the mode between heating, cooling and ventilation, you can change the fan speed, remotely via MQTT, of course the set temperature, the screen lock, and I think that's pretty much it. So this sketch establishes two-way communication between the device and MQTT via different topics. The only other thing I've implemented is that whenever it's communicating with the Modbus slave over Modbus, it is checking whether the communication is successful, and if any errors have occurred, then it prints the error onto the serial output and also into the MQTT topic. But for some reason I can't figure out why this MQTT topic publish of the error doesn't work. So I'm just not getting the errors, but everything looks fine in the code. So hopefully that's something that I will be figuring out in the future. The only other technical bits which I have done is instead of using the built-in serial port, which is also used to program the device, I'm using a software serial port. So I can still have this connected into my computer, and I can use the serial output to see what's going on, and then have the chip communicate with the Modbus device on a separate software serial port. First of all, let's have a quick overview of the Android sketch. And so this is going to be for those who don't really care how it works. They just want to implement it for their system. And as you can see, I have the file here. It's a single sketch file with an additional ntp.h file, which handles all the system or internet time traffic or functionality. And also I have the debugging window, so you can see that we have the ESP connected now. It's getting messages from my thermostat, so it is running at the moment. And as you can see, I'm using a few different libraries for this particular sketch. Most of them are like standard things that you get with the ESP8266 if you have the Arduino IDE properly configured for the ESP8266, so I don't think I really need to mention them. The other two additional ones that I have installed for this one is a software serial, and as you can see, I'm using this one, which is the ESP software serial. I'm not sure if it really makes a difference. This is the first time I'm using software serial, but it says that this library is designed for the ESP8266 as opposed to the standard one, which is more for the AVR or Atmel chips. Again, not sure if that's the one that we should be using, but again, I've obviously taken examples from other sketches, so they were using the same ESP software serial. And the other one is the actual Modbus master. There are a couple of Modbus libraries out there. This is, I think, the first one, which is actually a Modbus master, not a Modbus client. And as you can see, this library supports all the Modbus functions, but we are only using number 3 and number 6 for this particular device. So yeah, that's it. So download the zip, put it into our libraries folder, and after that your sketch should compile. The other changes you need to make are basically all here. So first of all, there is your Wi-Fi SSID, your Wi-Fi password, your MQTT server IP, and your MQTT user ID and password. I'm not using secure or TLS in my MQTT, so this is implemented using just user ID and password in, unsecure connection to your local MQTT server. So if you need security ones, then you probably have to modify the code more extensively. I've never done that before, so I don't know how that works. Also, we have an MQTT client ID. You can just rename it to whatever you want, and then a root topic. And of course, that can be, it doesn't have to be just one single topic. It can be like /home/ ground floor / living room / something like that. What I put in here as a remark that just always put a / at the end, because then I would be expanding this topic with read and write and some of the other topics that are sort of hard-coded in the code. But yeah, so you specify the root topic here. And then I have a few other options here. So most of the basic system settings are defined here in this section. And I don't think we really need to modify this one. I mean, 9600 is the Modbus speed, and that cannot be changed, so that should be left like this. The serial speed as basically this serial speed if you want to monitor the device, and then the connections are here, and this is why I didn't really want to go into details of the wiring, because actually it's all documented here. So D1 goes to DE, D2 goes to RE, D5 to RO, and D6 to DI on the ESP. And of course you have to provide VCC and ground, so 5 volts and ground to the RS485 module. Slave ID, again, default is 1. So that most probably is going to stay 1. Status LED, yeah, that's the blinky blue LED on the VMOS module. And the Modbus update frequency, so that's every second. And then the MQTT update, which sends information like the uptime and the RSID is every 10 seconds. And that's what you can see here, this MQTT status. And otherwise, the Modbus status or the Modbus values, as you can see, are being generated every second. And that's pretty much it. As again, if you just want to upload this, make these changes, and then compile and upload. Oh, sorry. One more thing here in the ntp.h, you scroll down here and you set your latitude, longitude, and the GMT offset in minutes. So this is required so that the time update, which updates the time on the unit, is going to be correct. And for the sake of completeness, I'm using these settings to upload my sketch to my VMOS D1 Mini. And to give you the rundown of the different features, and well, actually what you can see on the debug window is, let me turn off auto scroll and also let me reboot the ESP. So I'm just clicking reset. So now it's trying to connect to my Wi-Fi network. There is quite a bit of messages in the beginning, so that's why I'm stopping the auto scroll. So yeah, it connects to the Wi-Fi network, then it shows you the IP address, the signal, and then it's giving you a couple of messages like the Modbus line is set up, and then the UDP and blah blah blah, and it's waiting for sending the NTP packet, and it's getting all the NTP update. So that's the correct time and date for me. And once that is done, you will get this stream of messages. So once every second, then the ESP is going to query the thermostat, and it will print all the values here and also sends them over in MQTT. And every 10 seconds, we are also getting a status update. And that's pretty much what is going to happen. If I start, changing the set temperature, then you can see how I've moved the set temperature up. So basically, in the next second, you will get all the updates. And this is how it looks like with this more refined board. And as you can see, I'm using this High-Link mains to 5 volt 0.6 amp power supply, and it is powering the VMOS D1 Mini and also powering the the TTL to RS485 converter. And I'm actually powering it from the mains, which is connected to the same mains output that is powering the Beca device. This is still quite a big board compared to the actual thermostat, and like this, I don't think it would really fit into a wall socket. But you can, decide to remove these pin headers and then have wires directly running from the board of the VMOS to the board of the RS485 converter, and also remove this one. So this can be made a lot more compact and probably, make it 2 parts so it fits around the back of the device. So of course, probably the biggest thing is going to be this power supply, but hopefully you can find enough space for this in your wall. And that's pretty much it. Really, it took me probably like 10 minutes to solder this board together, so that's not a big deal. And I have also modified my NodeRED flow slightly from the previous example. As you can see, the top is pretty much the same. The difference is mainly here. Previously we had a couple of, well, actually it was one Modbus read, and it was feeding all the different sensors, the different text elements on the dashboard. But instead, what I'm doing now is I am reading all these values separately and sending them over. So in a couple of places I just have some, for example here, the ambient temperature and the target. Let me actually show the debug. The ambient temperature and the target are coming through as text, so I'm just converting them to numbers, parsing them. So if you can use this to make basically comparisons if you want to build your own separate flow. And in here, in other cases where we have the power values, which is like a simple 1 and 0, and that's being switched here, and then in this change node they are being replaced by actual text, which I'm displaying on the screen. And by the way, the UI part of it hasn't changed. So as you can see, I'm still getting, so I'm changing the set temperature on the unit now. I'm moving that down. And as you can see, the update comes through. I'm changing it to heating. And again, we will see, I changed the fan speed. So I'm changing it to heating, and then the Nest thermostat response, and then you can also see the changes here. And I can do the similar settings here, so I can switch the power. Sorry, it took a little bit of time. And I can also turn off the power and then turn on the power, and then those changes would get updated. So now it is a little bit slower because it's also the MQTT needs to go back and forth, but you see these changes being sent. And by the way, every time we are sending something to the device, you can also see these messages in the debug. So we have received something in the power topic, and then the power got updated. And similarly, if I change the, let me move this set temperature down, you can see we are getting all these different set temperatures, and then the set temperature was set. I just need to, oh, sorry, too quick. Need to switch the unit back on. And by the way, within the code, I try to make a couple of changes here. So for example, in this convert function node, and one of the things what I'm trying here is to minimize the number of messages going back and forth between the MQTT nodes and this Nest UI to decrease the unnecessary number of changes, and that's why you see some delays. But I think in normal operations, when you change something, you don't change things like every second, so it shouldn't be really a problem. And the other thing I want to show you is how this unit is sending the messages. As you can see, I decided that every time we receive the data over the Modbus line, the ESP actually breaks it up, converts some of the data, for example, it converts the temperatures, and then it sends them out in separate topics. So let me just switch off this debug, and then as you can see, that each of the topics starts with the root topic, which is defined in the top of the code, and then it says /read and then / the value. So every second you are getting values like, it starts with a power. So you are getting power, the fan, the mode, the target, which is the target temperature, the ambient, the lock, the valve, and weekday and time. So you are getting these, I think it's probably 11. So these 11 messages all at once, every second. And then there are a couple of write messages that you can also write to. So those are only, well, the only thing which makes sense changing is the power, the fan, the mode, the lock, and the target. The target is in the target temperature. And you always send in the codes. So for power, it's 0 and 1. For the fan, it's 0, 1, 2, 3, which is auto, high, medium, and low. I think these are the codes. But you can check the codes up here, where it gets broken off to various texts. And you just send that code. I mean, it was just like before with the Modbus version. So these are the values that the unit expects in the separate registers. The only difference I have done is when you are setting the target temperature, you are actually writing the normal Celsius temperature value, and then the unit will, the ESP will times it by 10 and then put that into the register. But again, that's all you need to remember. You are getting all these messages, which are always start with /read, and then you can read these /write/ messages. And that's basically how you operate the device from NodeRED or any other home automation system which supports MQTT. As I mentioned before, I've also implemented some sort of error handling into this catch. Error handling as in errors occurring on the Modbus part. So for example, if I unplug this thermostat, so I'm just pulling the mains plug, then obviously there will be no response on the Modbus line. And the way the device handles that is that it prints this error message. So, and the error text is the actual error code from the Modbus library. So there are a couple of error modes. It looks like this device basically only creates a response timeout, because every other time when either the value is wrong, so for example, if I try to put like an invalid value to temperature or into the power, then there are Modbus error codes which equal to like invalid value or something like that, but it just doesn't respond. It basically just ignores the data. So the only thing I was able to generate is this response timeout, which is actually quite useful, because then you know that there are some issues with your Modbus device, so it's not powered or something. And as soon as I plug it back, as you can see, we start receiving the messages again. So I think that's pretty much it. The link to this code and also to the Modbus flow is going to be in the video description, so you can just find that. And the sketch is going to be on GitHub, so you can have a look at that and then download and then change the settings and then upload it to your ESP. And now let me talk about the code in more detail, especially for those who would like to use this example to develop their own Modbus gateway, Modbus MQTT gateway, because as I said, each device is different and I think it would be more complicated to build a generic gateway than to adapt it to the specific device that you are using. Maybe I should start in setup, and actually I have to find setup. So I've already discussed the declaration, and in setup we don't have too much stuff, so we are just basically setting the stuff. We are setting the pin mode, so all the different pins, whether they should be outputs or inputs, and writing some initial status. So if you have these two control lines which control the read and write or receive and transmit, so they should be 0 and 0 by default, which is their initial value for receiving data. And then we are connecting to the Wi-Fi. If you can't connect the Wi-Fi, we restart the ESP. And then once we connect the Wi-Fi, we have to set up the Modbus object as well. So this is where you pass the slave ID. And you have to define some event callbacks where you are setting the transmit and receive flags. And they are basically here, and they are just setting the digital outputs. And then we connect to the MQTT, and then we send out the NTP request. So that's to set the time and the date on the Modbus device. And since we are here, we have actually, then let me go to my main loop. Yeah, so the main loop is here, and it's basically just handling the different events that might come into the ESP. So if we have an HTTP event, we need to handle that. Then we are always checking if we are connected to the MQTT, and if we're not, then we try to reconnect. And also we calculate the uptime, and we also calculate how many times elapsed since the last NTP time update. And if it's more than 1 hour, then we request a time update again. So every hour it checks the internet time. And talking about this uptime, I forgot to mention something which we probably see here. And also I mentioned this a couple of times before. So we have every 10 seconds, we have this MQTT status send, and that basically sends out 2 additional MQTT messages. One is the /RSSI, which is the Wi-Fi strength, and the other one is the uptime. So this is running for 15 minutes now. The uptime is in minutes. I just use this on all my ESP devices, and I just use these values to monitor that my ESP is running fine, it hasn't been restarted, and just basically housekeeping stuff. Let me go back to the code. So this is why we need the uptime, so we can send that uptime out. And that's all there is happening in the loop. So let's go to the top of the sketch. Yeah, I have a separate function which sends out the Modbus errors, and as you can see, it basically goes through all the different errors that are defined in the Modbus library, and I'm just converting them to text. So as you can see, there are stuff like illegal functions, data address, data value, slave address, blah blah blah, and then I print the error into the output, and this is what we have seen here, like response timed out, and it is also getting sent to an error topic. So in my case that would be /Beca/error, and I can't figure out why this is not working. So I can see these messages in the log, which is clearly this line, and then this part, which I'm pretty sure it gets executed because, well, the ESP doesn't dump and everything is running fine, but for some reason I can't see these messages. Maybe something in the conversion, or the data which is being sent out is like nothing, and then the MQTT server ignores that, but I haven't managed to figure out just yet. This timer callback is, I haven't mentioned it above, but I also created this OS timer, this timer object, which is set up to trigger every second. So every second this executes, and that basically does all this that you can see here on the screen. So it checks whether it needs to update read the Modbus update or do the Modbus update. And then, yeah, if that is true, which is basically every single second, then it, as you can see here, it says Beca.read holding registers. So that's function free in the Modbus, which is called read holding registers. So it's really easy to call these Modbus functions because in my particular case, Beca is the name of the Modbus object that we have created. So you just call a method of that, which is called read holding registers, and then you provide the base register and the quantity. So exactly the same settings that we had in NodeRED. So we are reading from register 0 and we are reading 10 registers. And the result gets stored in an array. So as you can see, then you can use the again your object and dot get response buffer, and then you specify basically which address in that response. So if you remember, address 0 is the power. So I'm just, you know, printing it out here. So what is the value of address 0? And then I'm also sending it to MQTT. And I'm just basically doing the same for every single register in this buffer. So 1, 2, 3. Some of them gets converted, divided by 10, but all the others are just basically sent out. And well, of course, there is some conversion here for publishing it on MQTT, because this method expects like a, I think, character array or something. But not an awful lot happening here. Just reading, going through this response buffer, and then printing everything onto the screen and also sending it to MQTT. So that should be really easy to change if you are using a separate device. And that's all. And yeah, and right in the top, we are checking whether the result, which is an integer value, and that's the return value of these read holding registers, whether that result is KU 5 MB success. So that's basically that the Modbus read was successful. And if it wasn't successful, then I call this send Modbus error function, which is supposed to print the error onto the screen and also to MQTT. And that's it. I also have these digital write methods, and that's basically just blinking the blue status LED on the VMOS to indicate some Modbus activity. So that was all the Modbus update, and also I'm checking here if I need to send a status update, and if I need to do that, again, I'm sending some stuff out to the RSSI and the uptime topic, and that's pretty much it. Simple. The Reconnect method is the standard Reconnect method for that I've taken from the like a basic example. Everyone uses that. The only piece of this function which is mine is these 4 lines, which basically responds to all the write topics. So that's those I think 5 topics that I mentioned, like the power and the fan and the mode and the lock and the target temperature that you can change. Okay, setup we talked about. Handle NTP response is again an example that I pretty much just copy and pasted and did very little modifications to, and that's reading the the UDP response from the time server and then just doing all the calculation to get to the actual time and date which we are then going to use and then send over to the Modbus device. And it also works, there is this summertime function which can also calculate whether we are in DST or not. So then we just add 1 hour to the current epoch, which is like the standard Unix time or C time. And once we have done all the calculation and we have the time, then we just send that time to the Modbus device. And again, it is really simple, very similar to the reading a register. As you can see, again, Beca, which is my Modbus object, dot write single register, the register ID, and then the value. Yeah, simple as that. And again, you are getting a result. You check whether that result is a success, and if it's not a success, then it was an error. So I just print the errors. And then I do the same. So register 5 is the minute, register 6 is the hour, and then register 7 is the one which is the weekday. And I have added this 5 millisecond delay in between because in my earlier tests, the minute and the weekday got updated, but not the hours. So I figured that maybe the ESP is sending these updates very, very quickly, and the thermostat wasn't able to process them. But I'm not really sure, but again, adding the 5 delay resolved that issue. This callback function is a copy of the example MQTT callback function. I should have renamed it to MQTT callback, but I didn't. And in the beginning, I'm just printing all this stuff to the screen, to the serial, like what was the topic and the message. And then here I'm making all these validations, like, okay, was the topic write/power? If it was, then I just write that information into, again, single register, power is 0, and a little bit of conversion of the payload, which is a character array, to integer, which then accepted by this Modbus object. And another little bit of things which I had to do is not only here in the write single register, but also in all the Modbus communication, that because we are using software serial, and if I disconnect the device, then my ESP used the short dump. And with a little bit of Googling, actually, I found out that that's because we are using the software serial, and because we are not getting a response quick enough, the watchdog timer resets the ESP. So every time where you use any of the Modbus functions, as in like reading Modbus device or writing a Modbus device, before that, disable the ESP watchdog, and after that, enable the ESP watchdog. Just like above, I'm storing the result, I'm checking whether the result is success. If it's success, I just print the message that power was updated, which we have seen here in the serial, and otherwise I print some errors. And I do exactly the same for the other few topics that I support. So write/fan, write/mode, write/lock, and write/target. That's pretty much it. As I said, the timestamp conversion happens here in the code. So that was the MQTT callback, and after that we have a loop, which we already discussed, and that's the end of the code. So as I said, not awfully complicated, and this is why I said I think it's easier to modify this for every single device that you would use, rather than having a generic Modbus to MQTT sketch. But I think that's pretty much it. This video is getting long anyway, so I hope you will be able to use this sketch for this thermostat and maybe for some other Modbus devices. It was kind of a fun project. It didn't really took a long time, and I think I was lucky with the wiring, because as you can see, with all these different enable lines and also the RX and the TX, there are chances that you wire something the wrong way around, and everything seems to be working, but nothing is working. So I was lucky that pretty much everything worked for the first one, for the first go, and well, I was able to build this one in pretty much in a day. As I said, links to the various libraries, the NodeRED flow, to this sketch, which is on GitHub, is in the video description. Thanks for watching, and hopefully see you in the next video.